Thermodynamics is a very interesting subject that deals with heat, work, and the interaction between matter and the heat energy. A thermodynamic system consists of a particular matter which is confined within a boundary. This boundary may be imaginary or a real physical boundary. It may be a conductor or a perfect insulator. This thermodynamic system has several properties such as pressure, volume, temperature, entropy, and internal energy. When this thermodynamic system changes state from one equilibrium to another equilibrium, then these properties change and a thermodynamic process is said to be occurred. This thermodynamic process can be of several types such as isothermal, isochoric, isobaric, adiabatic, and polytropic. Let's understand this process one by one. First of all, let's talk about isothermal process. Iso means same and thermal represents temperature. So any process in which temperature remains constant is known as isothermal process. Other properties such as pressure and volume may change, but temperature remains constant. For example, let's take a cylinder which has conducting walls and a piston is fitted inside it. When the piston is moved very slowly, then the pressure, volume and temperature, all these properties change, but the movement of piston is too slow, and that's why the gas inside the system has enough time to dissipate this heat through these balls, and that's why initial and final temperature of gas are identical. This type of process is known as isothermal process, such as when a solid melts and turns into liquid, it absorbs heat, but the temperature remains constant, and that's why this is regarded as isothermal process. Next one is isochoric process. Similarly, iso means same and choric represents volume. So any process in which volume remains constant is known as isochoric process. For example, let's take a rigid closed cylinder which has conducting walls. When you supply heat to this cylinder, then its temperature and pressure both change, but this cylinder is fixed and rigid, and that's why no change in volume can occur. This type of process is known as isochoric process. There is no any physical movement of any part, and that's why no work can be obtained in an isobaric process. The next one is isobaric. Bar is a unit of pressure, so any process in which pressure remains constant is known as isobaric process. For example, let's take a cylinder which has conducting walls and a piston is fitted inside it. This piston has no resistance and completely free to move up and down. So when you supply heat to this cylinder, then the pressure and temperature, both these properties change. But as we know, this piston is free to move, and that's why high pressure inside the cylinder exerts a force on this piston, and the piston moves until the inside and outside pressure become equal. We can see that initial and final pressure both are equal. That's why this process is known as isobaric process. There is a physical movement of the boundary, and that's why work can be taken in and out of the system. Now let's move to adiabatic process. In this process, all the properties such as pressure, volume and temperature may change, but there is no direct exchange of heat between system and the surrounding. For example, let's take a cylinder which has insulated walls and a piston is fitted inside it. When we move the piston, then the pressure, volume and temperature, all the properties change, and this type of process is known as adiabatic process. Polytropic process is quite similar to adiabatic process. The only difference is that in a polytropic process, the system may exchange heat with the surrounding. It means the walls are not perfectly insulated. They may exchange heat with the surrounding. A polytropic process is governed by this simple equation. P is pressure, V is volume, and N is the polytropic index of the gas. All the previous processes are specific case of polytropic process, which value depends on N, polytropic index. If its value is 0, then it's isobaric process. If it's 1, then it's isothermal, and for infinity, it's isochoric. For any other value of N, it becomes adiabatic process.